Good day, everyone. Welcome to CloudSec 2020. I'm Christina T. Bautista, Solutions Architect from Trend Micro Philippines.
My name is Johnny Principal Solution Architect in Trend Micro, joining from Singapore.
In this session, we'll share why Network IPS is relevant in cloud, and Johnny will show us a demo and some use cases on how Network IPS will protect your cloud infrastructure. First question, Johnny. Is Network IPS really relevant in the cloud? Why is it needed? And why do we need a Network IPS if we already have a host IPS installed per cloud instance?
Yes, that's the most asked question I receive nowadays. So let me start with what Gartner talks about it. So there is a Gartner Market Guide report for next-gen IPS that published last year. Then I believe that also applies to cloud environment as well. So according to this report, next-gen IPS is recommended to use as a virtual patch to prevent exploitation of vulnerability. Around 90% of all vulnerability over the last decade is accessible from the network, which means network-based IPS will be ideal technology to address this persistence problem. Then you might think about next-gen firewall. There's IPS function in next-gen firewall. But Gartner highlight around 70% of all the reduction of performance once you turn on the IPS in the next-gen firewall. Next-gen IPS also recommends the another layer of protection, so-called defense in depth, if you really need best-of-breed detection efficacy. So you could use next-gen firewall primarily for the firewall, and you could use standalone IPS as another layer of protection if you really need best-of-breed detection efficacy. And another concern you might have in cloud environment, whether you can get the same level of protection like on-prem IPS, then you don't need to worry about it. You will get the same protection. You will get the same zero-day protection. That is tangible benefit that every Trend Micro customer enjoy with the tipping point solution. And you can use cloud IPS, not just for the IPS, but also for risk-based vulnerability management solution that allow us to turn on the virtual patch based on the risk you might have internally or externally. And we fully support third-party threat intelligence like Stix and Hexi.
Johnny, in the cloud, most communication and traffic are already encrypted. How can we use cloud IPS to inspect encrypted traffic then?
Yeah, that's also really good questions. As more traffic become encrypted, a blind spot is being created, which means without SSL decryption capabilities, all the threat intelligence we have become useless. We cannot use this threat intelligence on encrypt traffic. So this data pulled from Google, 5 commonly used platforms by Chrome browser for HTTPS. As you can see here, blue line, which is Windows, year 2020, over 80% of traffic has been encrypted. Yellow line, this is more than 90% traffic has been encrypted. And all the platforms continue to increase for HTTPS. So I'm gonna show you live demo on how Trend Micro address this SSL decryption problem. This is my demo lab, runs in AWS. I have VPC1 and VPC2 and 3. In VPC1, I have a public subnet facing internet through internet gateway. And I have a 2 private subnet, and there is a cloud IPS between 2 private subnet. Cloud IPS managed by SaaS-based Cloud One network security or on-premise security management system. During this demo, I'm going to use SMS to manage cloud IPS. And then I have a SSL server here. So cloud IPS protect my SSL server. And VPC2, I have 1 subnet and I have a Kali Linux and command and control server. Then VPC3, I have some application like a Bitnami. All VPC connect through transit gateway. So when I try to access my SSL server, traffic flow looks like this.
How do you ensure that the traffic will be routed to the cloud IPS? How do you do that?
Yeah, that's really interesting question. So when I assign PIP, public address, to my SSL server, actually the one-to-one net address already created automatically in Internet Gateway. This is the net. So when I try access 18.141.22.140, IGW translate to 10.1.3.217, which is my private address of my SSL server. And then I need another routing. So I create an ingress routing in IGW. So any traffic going to 10.1.3 network, next up is external interface of cloud IPS, which means this is the external interface. This is the internal interface. So traffic forwarded to cloud IPS, where IPS inspection traffic, inspect the traffic. After that, look up the routing table. And 10.1.3 is a local network. So IPS can pass to my SSL server. When SSL server returns to the client, there is a one default routing, which is the internal interface of cloud IPS. So traffic forwarding to the cloud IPS. Then IPS, same as usual, we inspect. If traffic is malicious, we block it. If it's clear traffic, we let it go. And I have a default routing to 10.1.2 network. And then traffic going to the 10.1.2 network, there's another routing. There's a one default routing. Because I going to the 52.74, so default routing, next up is Internet Gateway. So traffic go to the Internet Gateway and client. This is the how traffic flow. So overall, traffic going like this. Then if I try to download the malicious traffic, then IPS definitely inspect and decrypt SSL traffic, then we block it. So I'm going to show the live demo on this SSL. This is my demo lab, AWS demo lab. So first one, I'm going to open up my client. This is my SSL, my client. I'm going to access to SSL server. Before that, I'm going to show you IPS. This is my cloud IPS. So let me check whether SSL function is enabled or not. So now SSL is now off. That means IPS cannot decrypt the traffic. But other than SSL decryption, all function is working. So let me send some traffic, whether IPS really detect something. So let me send some Apache struts. Let me exploit some Apache struts and Tomcat hostcat. Just run this command, try to exploit the vulnerability. And then maybe Tomcat vulnerability. Okay, let me go back to the IPS.
So Johnny, this is the SMS appliance, right? This is where you manage the cloud IPS as well?
Yes, we support hybrid, which means single on-prem SMS to manage cloud IPS. In this case, I have two IPS here, cloud IPS. Then I have one on-prem IPS, a single management platform to manage both on-prem and cloud.
Oh, that's good.
So go back to my event. As you can see here, there's the two event generated. So one for Apache Struts, the other for the Apache Tomcat, which means IPS working normal without SSL capability. So let me go back to my client here. So let me try to download SSL component, SSL payload, movie poster. This is over SSL. So I downloaded the Parasite the file. So let me open up what it is. Oh, this is the movie Parasite. This is one of my favorite movie, Oscar Best Picture this year. Tina,
Wow, I haven't watched.
have you watching this movie before?
No, I haven't watched that yet. But yeah, I'll put that in the list.
Yeah. So actually, I insert malicious payload into this file. So whenever I open this one supposed to call back to my command and control server behind. So
Oh, okay. So
let me
there's
see.
malicious payload inside that screensaver.
Let me bring another my CNC server. As you can see here, I got already connection, which means I can do whatever I want. This is my remote access tool. So let me show something. This is my client. Then I have a memorable family photo. Okay. Then let me do asking for ransomware. I need some money. So I can do ransomware encryption. Are you sure? Yes. I'm asking about $150. Yes. Then as you can see here, the client side, all is already encrypted. Then you can see pop-up message. Your file have been locked. Pay me $150. Then this is my Bitcoin address. Then I can decrypt for your file. Okay? But I'm a nice guy, so
Mhm.
let me go back to my CNC server. Then decrypt. So all file is decrypted. So this is the REST server, this remote access tool. It's not just for the ransomware. There's many function here. You can do key loggings. You can turn on the microphone at the remote server, or you can turn on the remote camera as well, remote desktop. You can do whatever you want.
Wow, that's such a powerful tool.
Yes. So let me go to the IPS again. I need to turn on. So I want to block this. So go back to the IPS. Then I'm going to enable SSL function. Okay. Now SSL is on. So let me try to do the same thing again. My client, open up browser, typing for lab, Ruby Foster here. Let me try to download it one more time. As you can see here, something wrong. I received around 400 kilobyte. After that, I think it stopped, which means IPS detects something. So let me go back to the IPS. Oh, as you can see here, there is a malicious payload discovered. So IPS detect and block it here after decryption. So let me show you what cipher suite algorithm has been used between client and server. So this is the block by IPS. As you can see here, this is a cipher suite between client and server. So tipping point product is true inline proxy. So key exchange, they used ECDHE RSA algorithm. Encryption algorithm, symmetric algorithm, they use AES-256 GCM mode. And hash algorithm, they use SHA-384. This is the algorithm. Okay, this is all for my SSL demo.
Oh, wow. Thank you for that demo, Johnny. So we can actually use cloud IPS to inspect encrypted traffic, and that accounts to around 80, more than 80%, right? I love how you use the parasite backdrop to inject a malicious script for this demo. So what's your next use case, Johnny?
Yes, the first use case was for detecting SSL decryption for
Mm-hmm.
traffic coming from north and south. So second use case for application flooding attack, traffic coming from east to the west, so-called lateral movement. So here, go back to my lab again. I have Kali Linux here in VPC2. Then I have a Bitnami application web server in VPC3. So I'm going to send some traffic, especially HTTP GET flooding from Kali to the Bitnami server through the trans gateway. So traffic flow looks like this. So my assumption is somebody sneak into VPC2 and compromise Kali Linux as a zombie PC or botnet. Then I can create HTTP flooding from Kali to the Bitnami like this.
Okay, in this scenario, how do we ensure that the traffic from one VPC to the other VPC will be monitored and secured by your cloud IPS?
Yes, also routing problem. So
Okay.
actually I need to create routing in transit gateway because traffic typically just go through the transit gateway, doesn't go to the IPS. So we need to create a routing in transit gateway. So this routing is a little different from normal routing. So we need to define where traffic coming from and where traffic going to. So I created two routing here. So let's say I'm going to send flooding from Kali 84 VPC2 to VPC3 Bitnami server. That means traffic coming from VPC2 to transit gateway. Then I have two routing here. So traffic coming from VPC2 means second routing will be used. Then look at the destination. Oh, I have only one routing, default routing. Default routing is, this is so-called attachment. So when you look at the last two digits, 86, this is 86. It means any traffic coming from VPC2, then trans gateway routing to 86 attachment, like this. Then what if traffic coming from VPC1? Then first routing table will be used. And traffic coming from 10.1. Then you have two routings. Depends on your destination. Let's say I want to go 10.3. That means this is the 10.3. Next hop is transit gateway echo 7, which means this line. That means traffic coming from BPC1. Transit gateway look up the routing, then sending to the E7 attachment. So reach the Bitnami. This is how routing works. Then once reaching to this subnet, there's a default routing here, 0000. This is the internal interface cloud IPs because I'm going to send traffic from Kali to Bitnami, which is a 10.3. So 10.3, I have to use default routing. So default routing, internal interface. So traffic go to cloud IPS, internal interface. Where IPS inspect traffic, then we look up the routing again. In cloud IPS, I have a default routing. I point to 10.1.2.0. That's the default routing here. Once reaching the private one network, there's another routings because I need to go to 10.3 network. So there's a 10.3 destination. Next hop is transit gateway. So traffic directly go to transit gateway and then Bitnami server. So traffic flow for normal traffic like this. Transit gateway, cloud IP, then Bitnami server. What if I sending a malicious traffic? Then definitely IPS detect and block. So I'm going to show live demo on this. So I'm going to generate some HTTP flooding attack to the Bitnami server and how we mitigate this flooding attack. Let me launch client. This is Bitnami client 10.3.1.91. Then before launch HTTP flooding to the victim, let me go to the IPS. Now IPS working like a normal IPS. We have a feature called fallback, which means IPS become switch, no inspection.
When do you usually use that, Johnny?
A lot of reason for this. When you do the troubleshooting, it's really also useful. Or just for testing purpose, I wanna bypass everything without any encryption, then just go here, just enable layer 2 fallback. Means
Oh,
IPS become layer 2 switch. No inspection, but no downtime. Or so we have a two mode. For normal means IPS working like a normal inspection mode. So now
okay.
I just enable layer 2 fallback means no inspection. Everything is bypass. So now I'm gonna launch some attack. Before that, let me check the CPU utilization. As you can see here, my application server only 1%, 2% CPU utilization, really low because not much traffic coming to my server. So let me launch attack. As you can see, CPU spike 100% right away. Now IPS doesn't do anything, just working like a layer to switch, no inspection. So let me go to the IPS again. I'm going to enable IPS mode. IPS, look at the table. You can see here, CPU go down to around 50%, 47, 50. So CPU go down to the half, which
Oh,
means,
why don't block everything?
yeah, that's a really super good questions. Actually, I can block everything. That means CPU go down to the zero. But
Okay.
this is the application flooding attack, like a
Mhm.
HTTP GET flooding, which is really difficult to differentiate malicious traffic from a legitimate traffic. Application flooding itself is actually normal traffic. It's not a malicious traffic. So I cannot block everything. So how to do it? So we need a little different approach. So I create a baseline based on the normal traffic utilization. After that, anything above baseline, which means abnormal, then we take an action. We can block it. Anything below baseline, which means it's normal traffic, so we don't do anything. So that's why here I create a baseline already. So it's some traffic is below baseline, some is abnormal. So half blocked by IPS. So let me go to the IPS again. How to create a baseline. So I have a one rule here. So I create a one simple policy. Any source address, any traffic. Destination, this is my Bitnami web application, 10.3.1.91. Any traffic going to this port number 8, which means as a web server, then this is the rate limit. Rate limit means we control based on baseline. That's the
How
meaning.
do you how do you configure the rate limit, Johnny?
Yes, rate limit. So here we have rate limit from 50K BPS up to 40 gig.
Oh, okay.
So it really depends on your normal traffic utilization. In this case, I use the 50 kbps because my environment, this is normal traffic utilization. So I can get this number from kind of a learning mode. So I understand maybe Monday to Friday, around 50K is normal traffic. And then anything more than this 50 kbps, which means abnormal. So we can take action, we block it. You can do whatever you want. So rate limit based on the baseline.
Okay.
So pretty much this is a demo for the application flooding attack.
Okay. Thank you, Johnny, for the demo on inspecting SSL and encrypted traffic by the cloud IPS. That's the first use case. And then now you shared with us application flooding and by using rate limit to actually control that application flooding. Johnny, if I am already using Tipping Point IPS and I have my own SMS, I could already manage cloud IPS via the same SMS appliance, right?
Yes, correct.
But what if I'm a new customer and I just need cloud IPS? Do I also need to get the on-prem SMS appliance? I want everything in the cloud.
Yes, that's also common questions. So we have a SaaS-based Cloud One Management Console, Cloud One Network Security. So there's a 5 module currently. So if you want to manage Cloud IPS, just click the Network Security here. Then currently I have a 2 Cloud IPS, one for AWS, the other for Azure. Both Cloud IPS managed by this Cloud One Network Security. So you don't need on-prem SMS to manage Cloud IPS if you really need 100% cloud management. And we have deployment protection menu, which allow you to create cloud formation template that will be used to bring up cloud IPS quickly. So let me quickly show you how it works. Just click the deployment protection. Then you need to select AWS account. Then you need to select which asset you want to protect. In this case, I click BBC one, this one, victim. Then click. Then I need to key in API key for Cloud One Network Security. So we don't use ID and password. We use the API key for my account. So this is my key. Then next. Then it supposed generate cloud formation template that will be useful. This is a template. So just download this cloud formation template into the AWS. Then you can easily bring up Cloud IPS. It takes around a few minutes. This is for the Cloud IP demo.
Thank you, Johnny. So we just shared why we still need network IP in the cloud. The use cases and demo shared were both very informative. Thank you for that one, Johnny. And again, for new customers, they can use the Cloud One console for managing the cloud IPS. While for current customers and users, you can use Tipping Point SMS to manage both the cloud IPS and, of course, your on-premise Tipping Point IPS. Thank you, everyone, for tuning in. Again, I'm Christina, and I'm joined by Johnny from Singapore. Stay safe and see you soon.
Thank you. Bye.